Well, hello and welcome, Math 1. This is Mr. Robinson here with Mr. Robinson Q&A Power Hour. It is Friday, May 15th, and I know I didn't get one from you last week. That's my bad. I was ill. Actually, I went to I went to Laguna Creek to go run. I went to go run on the track. This is my second time since school closures that I've been on campus. The first time I went to pick up some papers to get things graded and do. This was way early on. This was still in March, mid-March. And there was this time, and this was last week sometime. Both times, I came back sick, came back sneezing. There's something, I'm allergic to our school. There's something in the air that's making it happen. With sneezing causes headaches and sore throat and different things like that, and it weakened my immune system, so it actually got me actually sick. So I don't know, there's something environmentally that's there, and I know that sneezing isn't a symptom of COVID-19, so I don't think that that's that, but I'm better now. I'm fine. There also weren't many questions at the time, and it looks like people got to use that time to ask more questions here, which is good, because both of this has to do with the congruent triangle stuff. I don't see many questions here on congruent triangles. I know there's one at the very bottom, and I think that's, save the best for last kind of thing, I guess. But here are the questions right here. Questions are asked and answered in the order which they are received. So take a look at them right there. Those are them. We have 1, 2, 3, 4, 5, 6, 7, 8 questions right here. You ask a question through the submission form, as always. Of course, guys, the questions will be down in the description section down below right here with timestamps as you need to see your answer to them. Always try your best to get questions based on the current week's material, so that, because the whole point of the Q&A video is to get you good for the weekend and that Monday, and maybe even that Tuesday if you want to finish work, because now assignments are going to be due at midnight on Tuesday instead of 8 a.m. or 11:59 p.m. I should say, the end of Tuesday day, so you can get that all taken care of. But I want you to have times to ask the questions, so Tuesday through Friday you get to ask the questions. I answer them on a Friday, and then you get the rest of the week to finish them off. Okay, but let's go ahead and take a look at these things here. Again, they're asked and answered in the order which they are received, and some of these were asked in the first week. So this first question here says, on the last problem of the test, I was confused and didn't know what to do. So the thing is, I don't think this has to do with the current distance learning assessment for weeks 3 and 4, because this was asked before I put up the distance learning assessment, because I put that up just on Tuesday. So my guess is this has to do with the week 2 distance learning assessment. So let's take a look at that. Because I don't know what the question is. Let's go to Google. Oh, I have a Google Classroom right here. Google Classroom, hit a Math 1 class in classwork. Here's week 4, week 3, and week 2. I'm going to guess it's this one here, if it was the most recent one at the time. Ooh, this is week 1 on it. I sure hope it wasn't a week 1 distance learning assessment that's put up there. Let's check it out. So I'm going to select a name, and let's see. Yeah, this looks like week 2 stuff, so this is good. It says week 1. That's my bad. I gotta change that. Okay, last question here. Okay, it's a 2-step inequality question and the graph that represents it. So let's take a look at this one, guys. I'm gonna go ahead and write it on this other thing over here really quickly. I got 4x plus 11 is less than negative 21. We're gonna find out which graph represents the solution of the set of the inequality. So I don't know if your question is how do you solve it or how do you graph it? Right, because it could be one of 2 things. So you have 4 different graphs here. Let's just talk about the graphs really briefly as the idea, not which one's the answer. But you can kind of see them colored right here, like this option A. It's colored, but you also see the open circle on this boundary point -8, but this right arrow going here. This one has a right arrow that's green, boundary point on -8 that's closed. So these two are the same, only an open and closed circle. It doesn't matter what color it is. And then these two go to the left on -8. One is open and one here is closed. So which one satisfies that answer? Well, we'll find out here soon enough. And I'm going to go to my handy dandy little smartboard thing right here. We're going to solve for x. And what you're asking is what value of x can I plug in here to satisfy the solution set? We can treat this really as an equals to, you don't have to treat it as a less than. Just remember that it was a less than. The reason I say treat it as an equal to is, can you solve this? Because if you can solve this, you can also solve the inequality one. Just, subtract 11 from both sides. Divide by 4 from both sides, you get x equals -8. Now notice that -8 seems to be the boundary point from the last thing, from the multiple choice thing. So we know that -8 was the boundary point here on out. The question is it less than or greater than, and how does the graph correspond to it? So like I said, treat it like that. Let's go back to less than here. This was a less than the whole way through. And remember, that inequality does not flip. Does not flip unless you multiply or divide both sides by a negative number. We just divided by +4 So the inequality doesn't flip. This should say x is less than negative 8. That's the answer, but that's not the graph. All right, that's the solution set. What numbers for x are less than negative 8? And less than doesn't mean closer to 0 in this case. Less than means to the left, and we think about that like on a number line here. And that's why that number line is drawn in that other case. So I'm going to go ahead and draw this kind of number line graph. I'm not going to get very fanciful. I'm just going to put a 0 here. We know that negative 8 is to the left of 0. And the numbers that are less than negative 8 are the numbers that are to the left of negative 8. That includes negative 9, negative 10, negative 11, things like these numbers here. Negative 4 isn't less than negative 8, even though 4 is less than 8. But negative 4 is greater than negative 8 because it would be over here. Numbers that are less than negative 8 are to the left. Okay, and that's what that thing would look like here. Less than is left. As long as your variable is on this side of the inequality, less than means left, greater than means right. So we're going to draw an arrow. Instead of drawing a bunch of points, we end up just drawing an arrow instead. We draw the arrow to the left. And the other question is, do we put an open or closed circle on negative 8? Well, if you saw me draw these little points here to represent negative 9, negative 10, negative 11, things like that here, you notice that I closed that circle because those are included as solutions. Negative 8 is not less than negative 8, so negative 8 will not be a solution to this inequality, so it doesn't get a closed circle treatment, it gets an open circle treatment. It says anything less than negative 8, even negative 8.00001 would work, but negative 8 does not. So the open circle indicates that. To the left means everything else does work. These don't. You can always double check your solution set by plugging in a number. You can plug in negative 10 and see if it works. I'm going to plug in 0. 0 is easy to do. What's 4 times 0? That's 0, and it wipes that out. I get a statement, 11 is less than negative 21. That is false, but that's good, because 0 was not expected to be a solution to this statement here, to this inequality. 0 does not work. These numbers work. If you plug in negative 10, you're going to get a true statement. 11 ain't less than negative 21, though. That's false, and that's good. That one checks out. So the boundary point was correct. The direction we put was correct. So the final answer to that one, now that it's probably too late to do the thing, so the fact that I'm going over it is whatever. Final answer to this thing looks like it should have been this one here. I don't know if that's, I guess that's C. I guess that's C right there. All right, so there's that question there. With that one down, let's go on to the next question. And the next question that's asked is, when you're graphing points and you need to find the distance between the 2 points, can't you just count the boxes on the graph and find the answer? Ooh, that's a good question. So what's being asked here? I need to get like a graph paper thing. Give me 1 second. What's being asked here is, are there other just more traditional ways to count other than what we're doing with this Pythagorean theorem distance formula stuff? Why isn't my, hang on, sorry, I'm trying to get my image here. I'm not sure why it's not popping up. Huh. Must be deleted somehow. I'll find a way to copy and paste this thing in. So I'm going to talk through this. We can count, so on a graph, if you have grid lines on a graph going all over the place. We are allowed, it's called the fundamental counting principle. We are allowed to count horizontally and vertically among the tick marks because those are proper distances that account for 1 over 2 over 3 over things like that. We can count horizontally and vertically. There's no problem with that. There never has been. There never will be. And as long as the increments are all ones. Okay, now I have it up right here. So I can count across. If I want to find the distance between 2 points that are horizontally distant from each other, like this point here and this point here, I can count how far away they are by going 1, 2, 3, 4, 5, 6, 7, 8. Right? They're 8 units apart. That's the distance. Likewise, I can do it with 2 vertical points, one right here and one right here. These are 1, 2, 3, 4, 5 units apart. But what if one was 8 units apart horizontally and 5 units apart vertically? Can I count down this way somehow and say like 1, 2, 3, 4? No, see, you can't do that because this, if you had a ruler and you measured that this other one that's in green was 8 inches away from this thing here, this thing isn't also 8 inches away. This is longer, right? This is longer. If I drew a straight line on this vertical bit right here, the closest distance between the blue point and the line is the perpendicular distance, this one here. Anything farther down the line is going to be farther away, right? It's going to be farther away. So they're not the same distance. So you definitely can't do something like 1, 2, 3, 4, 5, 6, 7, 8. And even if they're like diagonally like this, I can't just say this is 1, 2, 3, because the diagonal distances of a box are farther away than the horizontal or vertical distances in a box. In fact, do you know what the square root of 2 is? It's around 1.4 something. I'll just say square root of 2. This distance is the square root of 2 times larger than this distance here. If this distance is 1, this distance is about 1.4. So if you're asking, can I use 1.4? No, because it's not exact and because that's only for a perfectly diagonal bit here. So we do use Pythagorean theorem instead. And we do, and I suggest that you do it by the counting idea that we find out that these are 8 away, and we find out that these are 5 away, and we use Pythagorean theorem now that we know the 2 legs of this right triangle, and you say a squared plus b squared equals c squared, like that right there. And if you want to know here, is this no, this isn't a Pythagorean triple. If you want to know right here, this would be about the square root of 89. It's around 9.5. This is I can't say exactly. This is around 9.5 right here. So it's not 8, right? It's not 5. You got to do something else with counting, and you got to calculate something on those things. You're going to learn some more things on what are called Pythagorean triples. So there are some that you can forego, and you'll just know what a 3, 4, 5 triangle is, and an 8, 15, 17 triangle is. And special right triangles, 30, 60, 90 triangles. You're going to find out some things with them that'll help you, but you can't count diagonally, unfortunately. It doesn't quite work that way. Sorry about that, but that is the answer to that. All right, but thanks for asking that. Yeah, it's something that, like, hey, come on, can't you make it easier for us? There are some shortcuts you'll learn later. Maybe some geometry in Math 2 and Math 3 that'll help you out with that. All right, why is two-step equations with fractions so difficult? I don't blame you. Why is it so difficult? It doesn't matter if it's a two-step equation. The problem is it's a fraction. No one likes seeing things, and I want to point to an episode on Girl Meets World. I can't remember exactly what it was, but I remember which ones. Wait, what are the friends? Maya. Who's the main one? Riley. Okay, so Riley's friend Maya is like, she doesn't get fractions. There was one time she was trying to figure out, well, I eat 8 or 9 tacos, and someone's like, just eat 8.5. She's like, I don't get it. What is that? Or they're saying something like, oh, the taco place will close in like half an hour. She's like, I don't get it. She don't understand fractions. Fractions aren't fun to look at. Not for anybody. Look, even if we had to do, let me go back to this thing. Even if we had to do something like, what's 2 plus 7? 2 plus 7 is 9. But we would hate if we saw this as 2 over 1 plus 7 over 1 equals 9 over 1. I know that's still the same answer. There's nothing wrong with that. We just don't like the look of fractions. No one does. We like to think of numbers as just a whole. Is make it easier for ourselves, because it's a whole nother level, right? We're already reading left to right. Now we got to go up and down on some things, and we got to be able to compare them equally, especially when there's not a common denominator. What if this is a 3 suddenly? And now you have to solve this. Now you got to get a common denominator. So, and you're not asking about common denominator, you're just asking about fractions. Let's try and ease the pain a little bit, though, for what you specifically talked about now, two-step equations. And my guess is you're thinking about what we kind of saw in J.4 when you saw things like r over 2 minus 3 equals 5. Okay, and suddenly you have to solve this one here. So before we solve this one, and I'm going to leave it up, I'm going to give you another equation here that says 2r minus 3 equals 5. And I'll say solve this one. You're like, okay, no problem. We add 3 to both sides, right? So if we add 3 to both sides in this bottom problem, there's no reason we shouldn't be adding 3 to both sides on the top problem as well. 2r equals 8 here. On this one, add 3 to both sides here. R over 2 equals 8. No difference. It's the term that we got to get by itself with the variable, so we got to isolate it by moving the negative 3 over, by adding it over. No change. 2r means 2 times r, so that means we're multiplying 2 with r. In order to get r by itself, we have to use the inverse of multiplication. We have to use division. So we're going to divide both sides by 2 here. This divides both sides by 2 to get 2 over 2 to become 1. Now it's a fraction. Well, it's division. But that's what a fraction is, and that's what I want to talk about here. A fraction is division. What do I have to do to get r by itself right here? Instead of thinking of it like a fraction as r over 2, think of it as it is. It is r divided by 2. And I'm not saying guess and figure out, oh, what number divided by 2 is 8? You could, but that's not always the case. What do I have to do to get r by itself? If it's dividing by 2, we got to do the opposite of division to make it happen. So we multiply by 2. Notice the 2 over 2 here, just like the 2 over 2 here. They'll go away. But I got to multiply 2 by both sides here as well. So here we get r equals 4, but here we get r equals 16. that's just solving that one there. You know, there's more than one way to solve these problems here, and what I could have done instead, I'm going to erase the bottom equation now. What I could have done instead, and I recommend this depending on the problem type when you get more complex problems in math, I say if you don't like fractions like me, and it's an equation, get rid of them as soon as you can. I don't mean just cross it out. I mean, if you don't want to deal with fractions now, just multiply by 2 from the very beginning. If a number's dividing by 2, making it 2 times larger will mean the fraction will be gone. It will mean bigger numbers the rest of the way, and it will mean don't mess up when you do this. But if I multiply everything by 2 to start with, I would distribute this 2. Remember, the 2 times a number divided by 2 means these will cancel, but this 2 still has to multiply by this negative 3. So I would get r minus 6 equals 10. And then I add 6 to both sides, I get r equals 16. So you can get rid of the fraction immediately here. So why are they difficult? Because they're fractions. How do you get rid of fractions? It involves multiplication, because fractions means division. Okay. Some problems can be harder still. You can have a variable in the denominator, and I don't think you ran across those, so I'm not going to jump into those right now with you. If you want to look at those especially with me, hop on to Zoom, and we'll take a look at those ones together. But I hope that kind of carries through what you need to do specifically for two-step equations. Just takes 2 steps, and you got to determine how you want to do it from there. All right, so with that one down, let's go to the next question here. The next question that's asked is, what is the difference between supplementary angles and complementary angles? Well, I want to cover as many bases as I can. The basic one is, and complementary, I'm going to just adjust one thing for you guys just so you know this. It's me being picky, but it's so you know for the future. There are 2 different words. I'm going to talk about the word complement right now. There are 2 different words here. They're going to be spelled with one different letter. There's complement and there's complement. Okay. Complement is not used in math. A compliment is, I like your shirt. You know, you played that game very well, like that. That's a compliment. So when we say complementary angles, technically there's a big difference between supplementary and complementary angles, because I haven't seen an angle before that has been able to give you a compliment. Complement, this isn't just for angles. Complement is something that helps make something else whole, something that goes with it, you know. Milk and cereal. You know, milk is a complement to cereal. It kind of fulfills its needs to make it its whole. Thelma and Louise, you know, things like that. Batman and Robin. So those are complements to each other. Actually, I'm not gonna say Batman and Robin. Batman don't need Robin to be who he is. That's a complement. Now, I just wanted to make sure that you do that. Now, what is a complementary angle? It's not something that makes an angle whole. It's a kind of different word they say that. But it is 2 angles that add up to 90 degrees. Okay? Complementary angles add up to 90 degrees. 2 angles. Now, I want to state this again, because I know I stated this in the previous video that I did. A single angle cannot be complementary. It needs to be 2 of them. Again, think of the milk and cereal thing. At least think that it still needs a buddy. Even if it's not making it whole, it's making it 90 degrees. 2 angles can be complementary pairs. They can be a complementary pair. One angle's 50, the other angle's 40. That's a complementary pair. Okay? They have to add up to 90 degrees. A supplementary pair, now the word supplement, you might think of, hey, vitamins, supplements, things like that. Hey, yeah, that's a good idea. Supplement. I've said that my videos, my lecture videos and stuff on YouTube, those are like this Q&A video. This is a supplement to the curriculum. It's not required. It doesn't make it whole. It enriches. It gives it a little more. You know your milk and cereal? Let's add a banana to the side. You know, that's a supplement to the thing. That doesn't make the cereal whole. It's just another bit to it. So supplementary is in excess to what it is that we're doing. Supplementary angles are angles that add up to 180 degrees. And again, it's got to be an angle pair. 100 degrees and 80 degrees are supplementary. So 2 angles that add up to 180. If you see some of my old video things on how I do the, set up an algebraic equation, if you find out like, hey, what is the complement of 38 degrees? What's the complement of 38 degrees? I'll say, well, some number plus 38 equals 90. I got to figure that thing out. That'll be 52. If we said, what is the supplement of 38 degrees? I'd say, hey, x plus 38 equals 180. And that number is 142. So complements and supplements work in different ways like that. And that's the main way that I want to answer this question. The other part I wanted to say is Complementary angles don't appear in your parallel lines things, alternate interior angles, corresponding angles and stuff, all those ones. Your, I'll say them out loud and I'll list them. Your linear pairs, vertical angles, adjacent angles, the linear pairs, alternate interior angles, alternate exterior angles, same side interior angles, same side exterior angles, and corresponding angles. When lines are parallel, these angle relationships are either supplementary, adding to 180, or they're congruent, meaning equal. They're never complementary in those cases. Either they add to 180 or they are the same and stuff. So you're going to see a lot more supplementary things when it comes to parallel lines. With the triangle proofs that you're doing right now, probably not as much to do with supplementary, but you see those parallel line things a lot more. So hopefully that just answers that. I don't know. I know I went off the deep end with that one, but I wanted to make sure I covered what you asked, because sometimes I can't tell. All right, next question here is, can I please have more time on my assignments, please? Well, because you said please a second time, why not? You know, I'm not really doing too many grading penalty things right now. The problem is I probably won't get your grades up fast enough if you do it later. So some people who I only have the week 1 grade stuff up right now. I'm going to get weeks 2 and 3 up this weekend. I had to kind of wait for applied math. It's hard to explain. I'm not going to explain it, but I'm going to get them up this weekend. And then week 4, you submit that as well. I put on Khan Academy everything. Like, if you go to Khan Academy, it'll say that your assignments are due the 29th. Kind of true. You got to get everything done by the 29th. That's your last date. The problem was when I had something due, what's today, the 15th? If I said that it was due the 15th and someone did do it late, then your score doesn't show up on Khan Academy on the big spreadsheet unless I go personally into your activity log. But I won't know to go into it unless you told me, and then it just becomes, a big cluster, you know what. So instead I just said I'll make them all due the 29th, because now at least when you submit something, the score will go into the spreadsheet for when I do the grading. And I think that gives you some leeway when it comes to grade stuff as well. I can see you on the spreadsheet very fast with everyone else, and just goes to show. But things are due on the date that they're said they're due in Google Classroom. That means if I start grading then and there, you might see a 0 show up later. Although you can still make it up. I'm kind of fine with that. Teachers have probably been lenient when it comes to all this stuff with the distance learning stuff, and I'll be the same thing here. So can you have more time? Sure, not longer than the 29th, but your thing will probably show up as a 0 until you make it up, and then you tell me about it, and I have time to actually go in and change it. Okay, but otherwise, if I go and grade it before you do it, then it'll show up as a 0 until then. Just keep that in mind. So no more time than the 29th. If you still got to do some week 1 stuff and make it up, go ahead. But, that means you just got to work on that pace. You got to work on that pace more. Okay, next question here is, I don't really get it. You're not being specific enough to let me know what you're talking about. I will guess this has to do with this new week's worth of stuff with congruent triangles. So I don't doubt it. I know there's a question on congruent triangles later. I don't know how specific it is. Let's scroll down and look at it here, for how to solve them more efficiently. So yeah, when it comes to I don't get it, yeah, this is new, and we're not going to go full bore into doing all these things on proofs. I just did do some videos recently on proofs. Hopefully you looked at that before you decided to say the I don't get it part, in which case if you didn't, I'll say look at those first to make sure that you do or don't get it. The Khan Academy videos aren't abundantly clear on some of this stuff, so what I'm going to answer here with I don't really get it is going to be kind of the bottom part as well, focus on congruent triangles. So let's look together at what the Khan Academy video says and what you can make of it, okay? I'm not going to go into full detail like he did, but I will say some things that he didn't really say very specifically, okay? He starts by talking about making congruent statements, or being given a congruent statement to understand something about two triangles here. And I'm going to be a little different with it here. I'm going to give you triangle ABC, but here I'm going to give you triangle EFD. I am actually changing up the letters when it comes to this. I'm not going to say DEF because I want to make sure that you understand something very specific about this. Okay. Let's say you have a congruent statement that says triangle ABC is congruent to triangle EFD. Okay. What's important about this to know is that the order in which these are written does matter. And this is one of the best things I can say to you for this thing right here. The order in which they're stated does matter here. This is the first letter stated. This is the first letter stated. That means that these two parts, wherever the letters are within their triangle, they correspond with each other. That means their angles, their respective angles are congruent. If the triangles are congruent, that means that both triangles are equal in size and shape. Somehow. They may be transformed, reflected, rotated, and moved all different places, but they're equal in size and shape. That means that these two angles are equal to each other. The letters B and F are the second letters in both of these things here. That not only means that angles B and F are congruent to each other here as corresponding parts, it also means, look at the numbers 1, 2 for AB and 1, 2 for EF. That means this segment AB is congruent to this segment EF right here. Yeah, all of this stuff applies, guys. Every single bit of this. It's not just the angles that are congruent, but the parts where they connect. 1, 2 AB, 1, 2 EF. Segment AB is congruent to segment EF. That's what this means in this statement here. And the third letter with all the different stuff. That means that all the corresponding parts of these two congruent triangles are congruent to each other. Okay? That includes the segments, not just the angles. Now again, it doesn't matter how these things are transposed in here. Maybe this triangle EFD instead doesn't look like, hang on, maybe instead it's not rotated this way. And sorry that the letters are going to be kind of rotated with this thing right here as well. But maybe instead the triangle looks like this, okay? And it's drawn this way. But here's the letter E, here's the letter F, here's the letter D. A is still congruent to E. That means this one marking thing is going to match this one marking here. So you got to find out where it is and where it corresponds. What I recommend for some people sometimes is rotate your triangle back so that the corresponding parts are in line with one another, that they look like they're in the same spot, bottom left, things like that. So that's the big thing that Sal Khan talks about in his one particular video, and he refers to some things in another video with side stuff. I'll get to that in a second. What you had to start doing instead was go the other way about this, though. You had to be given two triangles, and you had to make your congruent statement. So I'm going to give you one, right? Yeah, you know what? In fact, here I'm going to go to iExcel. I think that's where we're doing it, right? Let's go to iExcel together. Let's ditch this grandstand. Let's find my recommended stuff with you guys. Where's my recommended learning, recommendations, recs? Let's find the recommendation stuff on side angle side, things like that. Let it load up. You have to make triangle congruent statements, and the thing is the order of your letters matter. So naming pairs, theorems, I think it's this one here. All right, so take a look. We have 3 different triangles here. 2 of them will be congruent in some form based on markings. Now side means, and actually, you know, let's quickly go back to that before we talk about this thing here. If you saw the previous drawing that I made, right here with these two things, we know, like, without the statement, and I asked you, are these two triangles congruent? You'd be able to say, well, 3 congruent angles, 3 congruent sides. Yep, and I would agree. This is undeniable proof that these two triangles are congruent to each other. You have 3 sides and 3 angles. What this thing tells you here, SSS, is saying, knowing all 3 sides are congruent, that the corresponding parts have congruent sides, is actually enough information for you to say that the triangles are congruent. That means they're equal in size and shape. That includes the angles. That means that somewhere, this angle, if these two triangles are congruent, this angle is going to be congruent to one of the angles in the other triangles. They don't tell us that, but knowing all 3 sides are congruent is enough. That's the same case with side, angle, and angle, side. That's enough information to deduce these triangles are congruent. That's what this says. You don't need to know a set of angles are congruent as long as you know all 3 sides are, or 2 sides in an angle, things like that. So anyway, so let's dive into this really quickly here. I don't want to talk so much about which ones are congruent, although you can see 4 tick mark things here. These don't have 4 tick marks. These 2 triangles are congruent to each other, but you got to find the parts that correspond. So what I'm going to do for you guys right now is I'm going to kind of notice that these 2 triangles are kind of a reflection of each other, though. Right? Here's what I don't want to do. I want to snip this thing over. Sorry that this is kind of taking some time. I got to sort this thing out the right way because I can't draw on this page because it's a web page. So I just got to copy it over, and let's bring it into here. I don't want to automatically go alphabetical here. By that I mean, QRSTUVWX. All right, so I don't want to I don't want to say that triangle VWX is congruent to triangle GHI just automatically. That's not necessarily true. In fact, I'm going to debunk it right now and show you that it's probably not true. I haven't looked, but I'm going to show you it's probably not true. V is the first letter here, G is the first letter here. That means these two angles would be congruent. That's not necessarily wrong. I don't know that yet. That's not necessarily wrong. And you have to actually... Oh, well, yeah, let's keep going further. W is the second letter, H is the second letter. So again, we don't know anything about the angles here just yet, right? We're not sure where they are in space. But let's look at VW and let's look at GH. VW has one segment part here. GH has one segment part. Okay, so far so good. VW is congruent to segment GH, so these two parts being in order actually doesn't seem like too bad of an idea. Now let's look at the next part. WX, right, from W to X, 2 to 3. That's the next letter. From W to X, that's a 2 tick mark congruent segment. H to I is a 3 tick mark congruent segment right here. This segment WX is not congruent to this segment HI. Something went wrong here. Something when it comes to the segments here. So the order in which these are written is not correct. We have to find parts that correspond. So you have a couple ways that you can do this. Some of them are mental and some of them are actually physical, if you don't mind redrawing these or anything like that. What if instead we took one of these triangles and we redrew it so that it was appearing to look the same as the other one? Here's what I mean by that. And actually, I can probably, I can't duplicate it, but what I'm going to do is I'm going to redraw another triangle to look exactly like GHI. I'm going to put the congruent marks in their place, and I'm going to show you where those letters will correspond. So if I draw this triangle instead to be facing the exact same way, because we know they're congruent, we just got to figure out where the letters go. Let's put the 1 arc mark here, the tick mark, the 3 tick mark here, and the 2 tick mark here. Where do these things go? Let's see. From W to V gets the 1 arc, the 1 tick mark here. From V to X gets the 3. So if I'm looking at W to V here and V to X here, that gets the 3. I guess V needs to be right here because that is 3 here and 1 here. 1 here and 3 here. X gets this letter. From X to W has 2 tick marks, and there's that W that goes here to V. So that's a good redrawing of this triangle right here. Instead of having the one that was essentially a reflection, remember it was reflection, they're not always drawn the same way. Instead, I can have one that's just a little bit fairer to what we're looking at. So these two triangles, let's bring it forward, these two triangles here are congruent to each other. So now I can make a congruent statement. Now here's the thing when you make a congruent statement. It doesn't matter which order you write the first set of letters. It doesn't matter. You can do alphabetically, you can do whichever order. I can say WXV. That's fine. Doesn't matter. The next one has to go in correspondence with what you did. If I say WXV, I'm saying this letter on top, then the letter on the bottom right, then the letter on the bottom left. Or I'm going from this angle to the 2 arc mark, around to the 3 arc mark. So let's make sure we go from starting here. From this letter to the 2 arc mark, around to the 3 arc mark. I'm going to go G-I-H. Triangle G-I-H, like that. This is a proper congruence statement here. There are a bunch of them because it depends on how you reorder these. If I put XWV, now it'll be IGH. Because again, the letter order is what matters. So that's one of the big things I want to talk about there if you say I don't really get it. Because that's what a lot of people have trouble with right now, is the order in which the letters are written. Okay, so the order in which they're written is super important. I've said it a lot more concisely in other videos because this one's a little just kind of unplanned thing. Let me go ahead and answer that question there now. And I'll put triangle WXV is congruent to triangle GIH. And they'll say that one's good. So again, the order does absolutely matter. Let me just point to one more here and just finish it because it's side angle side. So I need to find... So for side angle side, by the way, the angle needs to be in between the two sides that are congruent. That's true for all of these. But this one has 3 tick marks and none of these have 3 tick marks. So these two will be congruent to each other. This looks like a reflection again. Because notice how WY, the left side has the 1 tick mark, but this has a 2 tick mark. So you want to find this tick mark, go with this tick mark. You want to find this one, go with these ones here, and the bottoms are the same. So it's kind of a reflection. If I go from some angle to the 2 tick mark to the angle to the 1 tick mark, I want to do the same thing here. So DBC, let's go XWY, right? To the 2 tick mark, the angle, and the 1 tick mark there. So I'll say DBC and I'll say XWY. So there's more than one answer, or there's more than one way to write those answers there, but that's the general idea of that. That's all I'll say right now for the I don't get it question, and then when we do the more congruent triangle stuff, I'll help you a little bit more along the way. I know that was a lot, but hey, you asked the question. I don't know how to answer it because you just said I don't really get it. So I'm covering as much as I can. All right, so there you go. All right, so that ought to do it for that question there. And with the next one, we'll say, what will we be mainly focusing on this year? If by this year you mean the last 2 weeks, we are literally 14 days away from the end of the school year. Congruent triangles here until this end of this next week. And then we're going to throw some statistics at you. You've heard of mean, median, and mode. I don't think we're going to do standard deviation. Range, maybe interquartile range, box and whisker plots, histograms, some statistics stuff. Different from geometry. It's not geometry. It's not even algebra either. It's statistics. Different things, right? Math 1 covers some first semester algebra, first semester geometry, and statistics. Math 2, second semester algebra, second semester geometry, some statistics, I think. Math 3, algebra 2, and some statistics, some trigonometry. So, yeah, got to cover some statistics. We're going to do that at the end there. That's all we're going to do here. So, congruent triangle stuff that you're looking at right now through Tuesday, statistics afterward. All right. That's going to be the end of that. And the last one, I need more focus on trying to figure out how to solve the congruent triangles more efficiently. So, I did answer, hopefully it answered it before with that. So, if you didn't hear this, the I don't really get it question, I covered a little bit of why the order of the congruent triangle statements matter, what it means to have side, 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 and things like that. It means it's enough information to say that the triangles are congruent, and how you can redraw them and such. Now, how about the proofs? Let's use this question to go to proofs. Once again, though, I will say, if you didn't refer to the example videos that I did before, refer to those first, because, you know, that was a half hour's worth of information, including some words, those terms. There are some new terms now involved, like reflexive property, alternate interior angles, vertical angles you've heard before. Now you have statements when things are perpendicular or parallel, midpoints and bisectors, all these things. Understanding the definition will give you more validation of a proof that a side in one triangle is congruent to a side in another triangle, or an angle in one triangle is congruent to an angle in another triangle. So I don't know how to say more than what I've already said before, so I'll say that I'll happily answer this for you, but I'm not going to go super in deep with it, because I already have before. And, let's see, what's it called? Level, I can go recommendations, huh? And, I've already answered it before, right? So anything that I answered before is going to be kind of a rehash of this stuff, but, you know, maybe you're more inclined to watch this one because this is when you ask the question. So let's find one here together. Let's do some side, 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 angle, side with proving triangles congruent. First of all, 2-column proofs. You're going to be doing a lot more of these at some point in Math 2, which means you are going to be constructing the statements and the reasons to prove a triangle's congruent. I might have said this in a previous video before, I might not have, but I like to think of, if this is building evidence for a conclusion, I like to think of it as, you know, things like court cases. Court cases, in order to convict somebody of something or to prove that someone's guilty of something besides their plea, say they're not guilty, find the proof around it that instead says that they are. And I know you can't see me here, so I'm going to go back to me. Full me, not full me here. So you build evidence. Sometimes some evidence leads to other evidence as well, right? You know that she was here. Or no, how about, you know that she wasn't with her friend. Therefore, she was also here. And if she was here, then she saw this happen. Sometimes some evidence leads to other evidence. Sometimes you can create evidence on your own. Sometimes there are some things that are just called givens. In these proofs, they are going to give us the givens. And by the way, if you're wondering why we're doing proofs, one reason is to exercise some of the properties that you have. But another thing is, I don't know if you guys know what a theorem is. Well, okay, Pythagorean theorem. Pythagorean theorem is a nice little formula. A squared plus b squared equals c squared. It helps us do certain things that we otherwise wouldn't be able to so easily. But a theorem, such as Pythagorean theorem, is a true statement that can be and has been proven. The Pythagorean theorem has a proof behind it. The quadratic formula, which you're going to learn in Math 2, has a proof behind it. There are ways to deduce what it is, and the proof means an undeniable way of showing that this thing holds water, that it's allowed to do and say. So why are you building proofs? Possibly with the respect and understanding that none of these things came out of thin air. There's more to it than that, but using the ideas of leading one thing to another, right? Everything you get in a textbook as far as a formula didn't come up out of thin air. It was created, devised, and proven. All the theorems, at least. The theorems were proven. So what you're going to do is you're going to build proofs here. And I'm going to go ahead and look at this last one here, or this, not this last one, but this particular problem here, this last question. And right here you have a given statement, okay? There's another given, so the given statement's written here, that's why it says given. There's another given statement based on the drawing here. These markings mean that it's given that this segment is congruent to that segment there. So we write it out because we can use that to lead to other information. Maybe it doesn't lead to these statements here. Maybe it does, maybe it doesn't, but maybe it helps lead to our final statement. Okay, so there is a line that bisects an angle. Now, when a line bisects an angle, I should probably put this on my other thing that I had. But when a line bisects an angle, that means that it divides the angle into two congruent parts. And again, that is taking a statement and helping you lead to another statement. The bisector thing is what we know. The fact that it makes congruent angles is what we get out of it. So I'm going to go ahead and go back to this guy right here. I'm not going to do the proof, well, I'm not going to write the two-column proof out, but I'm going to talk about what the proof says. It says that this line bisects this angle. That means this line divided this angle to two congruent parts, a part right here and a part right here. We have determined that these two angles are congruent to each other. And remember, we're looking at two different triangles. Here's a triangle, there's a triangle. We're looking at the angle in this triangle is equal to the angle in this triangle. And you can see this kind of looks like a reflection thing like the last couple of drawings that we've had. Okay. The reason is because of the angle bisector. When you see the reason, it'll say definition of angle bisector. We're given these two sides are congruent as well. One side and one pair of sides and one pair of angles being congruent isn't enough. It's not slam dunk conviction that these two triangles will therefore absolutely be identical to each other, equal in size and shape. You need at least the other side that's opposite this angle, or at least another angle. You can't have two sides like this and still say they're congruent as well. You'd still need more information. Angle side does not work. Angle side does not work as far as full proof evidence. If we could get this side, if we could figure out that this was a right angle, that would be cool. There's no way of figuring that out because here's an extreme example. What if instead it looked like this right here, right? No longer a right angle there. So we can't know that's a right angle, but what we can say, notice here that this is a shared side with both of these triangles. If you share a side in both triangles, that means that side is itself, right? So it's equal to itself. So I'm making a marking here saying it's equal to itself. But what I'm really saying is that the side in this triangle is equal to the side in this triangle right here, because in the object, it's a shared side. So segment TW is congruent to itself. That's called the reflexive property. And I know I've said it in the other video, but I'm just stating it again and showing that if you split it apart, that means the same thing there. So now you have a classic side angle side case with this side angle side. By side angle side, I can state that these two triangles are congruent to each other. Okay. Now you can make a triangle congruent statement like I did earlier, but they already give you one right here that works out just fine. And let's see that they have an order that actually works out. Triangle TUW is congruent to triangle TVW. TUW is TVW. And by the way, it's not always that one letter corresponds with the other letter as long as they're the same letter here. There are, in parallelograms, that doesn't happen. You have to find the part that is a corresponding congruent part, either angle or side. But this TUW is congruent to TVW. So you can see the parts that correspond. The TU with TV, the VW, UW, even though we don't know those parts correspond, the parts that didn't mark, WT, WT, and that T started this thing off and closed it off to make the angle there. So, okay, so that one seems to work what they said. The reason is side angle side right there. So as I fill this thing out in this last bit, and look, I don't know what more to say about this when you say you're confused on it, because I'm only doing as much, look, it's new. It's new for all of us. But you can see here, the two angles are congruent by definition of angle bisector. Mark it up if you can help yourself with that. Reflexive property says that that side is congruent to itself. And now we can use the side angle side conjecture right here to say that these two triangles are congruent. Your final statement is always therefore he's guilty. It's the last statement that they're asking you to prove. Prove this. Okay, that's your final statement. You don't need to say more. And then this, and then that. No, you're done. Side angle side, that one's taken care of. So there are a lot of different questions with those things. I can already see vertical angles right here. That means these are congruent. So I know that you're saying here within this question, you need more focus in trying to figure out how to solve the congruent triangles more efficiently. Remember, you're not solving anything unless you're talking about the final statement. But you are proving that the triangles are congruent. And more focus. You know, there are keywords that I have in my first video on side, 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 and side angle side. Maybe have that window open so you can see those words there and see if it can help you out and say, what kind of clues am I looking for? And they already gave you the statement, so you just need to validate them. But start to see how you can piece those clues together. Get some more practice in it. I don't know if that helped you out other than just me. You know, I want to calm your nerves by saying that it is hard. And I know that sounds weird by calming your nerves. That didn't make much sense. It is hard. It's different, and it's, well, when you get used to it, it's easy, you know, like everything else. Like some people ask me, Mr. Robinson, is the test hard? I'm like, well, for me, no. Right? If you know it, it's not hard. This new stuff, this is unfamiliar, very foreign territory, right? Very new waters for you guys, and it's not really algebra anymore, right? This isn't algebra. This is doing something way different. This is geometry. No, it's like, welcome to geometry. This is hard. This is all that geometry is. Geometry isn't only proofs. However, there are a lot of theorems, and all of those were proved, so, you know, it's likely you'll run into proofs a lot. But it's very visual. Some people like it more. When you ask some people, do you like algebra or geometry more? Some people will say geometry. Some of you guys wind up saying that as well. So, I don't know. It starts with the understanding that as long as you have enough information, 3 sides or 2 sides in an angle and stuff like that, that's enough to say that the triangles are equal. The order of the things matter, and it helps if you redraw them so you face the same way, or just make sure that the parts correspond with each other that you see to make your statement. And when it comes to these proofs, there are a bunch of new terms: bisector, reflexive property, corresponding angles, vertical, you know, things like that, alternate interior, parallel, perpendicular, a lot of new things. That's just with practice. That's just a practice thing. I can't tell anyone at any stage, no matter where you're at, that I tell you it the first time and you'll understand it. No, these ones need practice, and then once you see them more and use them more, you'll do it. I know some people will start saying reflective property and parallel angles and things like that. You know, they'll start making things up, but that's just a part of the process, guys. As long as you have someone to correct you and help you out along the way, that'll probably be good. All right, so that'll do it for this one. I know that I've overstayed my welcome here. A lot of people probably don't really watch these because they know how long they are, but I try and answer the questions that are asked. I want to hold my honor to that, especially since I didn't give you guys a video last time. You can consider this one to be a doubled up one. So there you go. All right, so that'll do it for this one, guys. That's it. We'll have transformations next week. So Q&A video hopefully will mostly be on transformations. All right, take care.